Good morning. I am Dr. Usha Rani, Professor, R&D Engineering College. I am going to brief about the topic of wattmeter. Wattmeter is an electrical instrument which is used for measuring the active power consumption by combining the measurements of voltage and current. Generally, active power formulas V voltage into current into power factor VI cos phi. We are going to see two types of wattmeters. One is electrodynamometer type wattmeter, which works on the principle of dynamometer principle. Second type, induction wattmeter, which is based on the principle of electromagnetic induction. So first method, electrodynamometer wattmeter, which works on the principle of dynamometer. That is, a mechanical force acts between two current carrying coils or conductors. Here there is a fixed coil which divides half on one side and half on another side. Okay, these two are in parallel to each other and they are connected in series with the load which is connected. Okay, and we have one more coil, moving coil, which is connected across the load through the series resistor. So there are two coils, one is moving coil, another one fixed coil. Fixed coil is divided into two half. One half was connected, they are in parallel and they are connected in series with the load. Okay. The fixed coil which is connected in series with the load we are named as current coil, and the moving coil which is connected in parallel with the load was named as potential coil or pressure coil, we can say. By seeing this diagram itself, if the wattmeter is connected in a circuit to measure uh, power, means if you take care of the current coil which carries the load current, okay, in case of potential coil, it carries a current proportional to the load voltage. So both are carrying currents only. Okay. So due to the currents in the coils, a mechanical force acts between them. This result, the pointer as the mechanical force deflects the pointer. Okay, so pointer will move here in the scale of the meter. So when the pointer comes to rest means if the deflecting torque and the controlling torque becomes equal. As the reversal of circuit current reverses the current in both current coil as well as the potential coil, so that the direction of deflection torque remains unchanged. So under this condition, it will be useful to measure power in both AC as well as DC circuits. In general, we are having one current coil which is connected in series with the load which carries current. Similarly, a potential coil which is connected across the load which carries also current, okay, proportional to the load voltage. Both are currents only. Okay. Due to this currents only, a mechanical force acts between them. This mechanical force deflects the moving coil and the pointer over the scale. That is the basic concept of electrodynamometer wattmeter. If you take care of induction wattmeter, which works under the principle of electromagnetic induction, if you take care of the diagram, There are two magnets here, one is series magnet, another is shunt magnet. The shunt magnet, if you take care, which is connected across the supply, okay, which is connected across the supply and carries a current proportional to the supply voltage. Generally, the coil of the shunt magnet is made highly inductive. That means the current flows through this will lags the supply voltage by 90 degree. That's why it is made up of highly inductive. In the case of series magnet, which is connected in series with the supply, okay, which carries the load current. Generally, the coil is made up of highly non-inductive. Okay, highly non-inductive. And here if you should take care of a thin disc is connected. Okay, a thin disc which is made up of aluminum is mounted on the spindle. So this is the aluminum disc. One spindle is connected between the two magnets, that is series magnet and shunt magnet, so that this will cuts the flux of the two magnets. So if you take care of wattmeter is connected up in the AC circuit, means a current flows through the coil of the shunt magnet. Okay, current flows through the shunt magnet which is proportional to the supply voltage, and the series magnet carries the load current. So the fluxes produced by the two magnets, shunt as well as series magnets, induce eddy currents in the aluminum disc by the action of electromagnetic induction. So due to the interaction between the fluxes and the eddy currents, a deflecting torque is produced on the disc. So it causes the disc to move. So the pointer which is connected on the disc moves over the scale. So when the pointer comes to rest means when the deflecting torque becomes equal to controlling torque. So the induction wattmeter works on the principle of electromagnetic induction, which can be used to measure AC power only. Thank you.